This video here is to show that the electric field is the gradient of potential. Now, what is the meaning of the word gradient? We will see as we proceed with the derivation. Now, what we have in here is we have a charge plus Q, which is placed at point O, and we have point B, which is distance r away from point O. And we also have point A here, which is a very small distance dr away from point B. Now, the electric field due to plus Q is E, and therefore what we want to do is we want to move a test charge Q naught. Say we want to move a test charge Q naught, okay, a test charge Q naught from point A to point B by a very small distance dr, by displacing it by a very small distance dr. So test charge is positive, always positive. Okay, so we have a positive charge plus Q over here. So due to this plus Q charge, we have an electric field which is in this direction, that is towards our right hand side. Now against the electric field, that is against the force of repulsion, we are moving our test charge Q naught from point A to point B. So in order to overcome this force of repulsion due to the electric field, that due to plus Q, we have to do work, we meaning the external agent. So the work that is done to move the test charge Q naught from A to B, traveling a very small distance dr, is given by dw. In order to move it by a very small distance dr, we have to do a small amount of work, dw. So dw is F dot dr, that is force dot dr. Now what is this force F? Force F is equal to Q naught into E, the charge that we are moving multiplied by the electric field from the definition of electric field. Alright, so F dot dr is equal to F ds cos theta, of course. Now what is the value of theta over here? Theta is 180 degrees because dr, the displacement is from A to B. So dr is directed towards our left hand side, whereas the electric field is directed towards the right hand side. That is, the force is directed towards the right hand side. So the angle between F and dr is 180 degrees. So cos 180 degrees being minus 1. So therefore F dot dr is minus F dr. And like I've already said, F is Q naught into E. So substituting the value of F in this expression, we get the work done dw to move the charge Q naught from A to B by a very small distance dr, okay, is minus Q naught into E dr. And let us say that this is our equation number 1. Now, due to this charge plus Q, we can measure potentials at B and A also. We can find the value of potential at point B and point A. Of course, since point B is closer to point O, that is closer to plus Q, so potential at B will be more and potential at A will be lesser. So we consider that V to be the potential at point B and the a lesser potential V minus dV at A. So the potential at A is lesser than the potential at B by this value, by this small value dV. So V minus dV is the potential at A and V is the potential at point B. Therefore, from the definition of potential difference, the potential difference between these 2 points B and A is the work done to bring a unit charge or to make a unit charge move from one point to the other. So the potential difference between points A and B is V, the potential at B, minus the potential at A. So this is the potential difference between the 2 points B and A. So this potential difference by definition is the work done to move a unit charge. So dw by Q naught is the work done to move a unit charge from one point to the other, from one point to the other. We've already seen dw amount of work is to be done, this amount of work is to be done to move charge Q naught from one point to the other, from point A to B. So this is the amount of work to move charge Q naught. So the amount of work needed to be done to move a unit charge is dw by Q naught. So, and that is exactly what the potential difference between point A and B is. So potential difference between point A and B is dw by Q naught. That is the work done to move a unit charge from one point to the other. That is from point A to B in this case. So dw by Q naught is equal to dV. Okay, so once you do the calculation here, mathematics, so this V, they cancel each other out. So dW by Q naught is equal to dV, or dW after cross multiplication is Q naught into dV, and this is our equation number 2. So from equations 1 and 2, you can see the left hand side, it's the same for both the equations. So we equate these two equations, and when we equate these two equations, what we get is, therefore from equations 1 and 2, we get minus Q naught E dr is equal to Q naught dV. So Q naught, they divide each other out, and thereby we get E is equal to minus dV by dr. Now dV by dr is the rate of change of potential with distance. This rate of change of potential with distance is what is called your gradient of potential, remember. So the rate of change of potential with distance is what is called the gradient of potential. And thereby from this expression we see that the electric field is the negative gradient of potential. And this minus sign is telling us that the potential decreases in the direction of the electric field, remember. That is what this equation is telling us. The negative sign is telling us. The negative sign tells us that the potential decreases in the direction of electric field. Alright, so to say, potential from point B, when we move from point B to point A, that is in the direction of electric field, because the electric field is towards the right hand side, okay, here in this case. So when we move in the direction of the electric field, that is towards the right hand side, the potential goes on decreasing. That is what the negative sign signifies or tells us. So from here we get to see that the electric field is the negative gradient of the potential, remember.